Hi, good evening. Am I audible to you? Let me know if I'm audible through the chat. Yes, let me know through the chat if I'm audible to you. Okay, thank you. Right. We'll wait for about 5 minutes and we'll get started, okay? So, as I have already recording the live session, you can watch the recording by clicking the live session link, okay? So, right, we'll wait for about 5 minutes till others join and then we will get started, right? Okay, so let's get started. So, good evening to everyone. I hope I'm audible to you. And we are going to start Unit 7. And I would say one of the interesting chemistry lesson for the grade 11 students would be acid, bases, and salt. So, in this lesson, you will be learning like you will be doing some kind of recap so unit 7 is there, right? So when you talk about unit 7 in the lesson unit 7, you have to recall unit 3 of your grade 10. Unit 3 grade 10 has to be recalled. That means you should know the periodic table, You have to know the periodic table, and you should know how to find the ions, the positive ion and the negative ion, like we say cation and anion. And also you should know polyatomic ions. Polyatomic ions. In this lesson, you will be recalling all of them. And then again, unit 16, lesson unit 16. In grade 10, also you will be recalling, specially balancing chemical equations. So you have to know all of these if you wanted to do this lesson in an interesting way. So this lesson is about acid, bases, and salt. And I would say only 3% of this lesson will be very important for your O levels. Only 3% of this lesson will be very important for your O levels. Other than that, like the main question, like if I wanted to say for the structured essay or the essay type question, you don't need much this, like you don't want to know much about this lesson. So always remember, this unit 7 lesson will be always connected with the unit 3 grade 10 or unit 3 grade 11. It's like a connection. They do not come individually. They come connected to some other chemistry lessons where you have to only face 3% of this lesson, and one of the easiest lesson, okay, easiest chemistry lesson, unlike the unit 9. So you will be learning unit 9 also, which will be a biggest chemistry lesson. So there are also you will be learning more about it. But anyways, so I will talk about the unit 7. So let's move to the unit 7, right? Okay. Okay, right. So now let's talk about the unit 7. So our unit 7 lesson is about acid, bases, and also we call it as the salts. So these are the things we are going to study. Already you know what is an acid, and you know what is bases, and you know what is salt, right? So now we are going to learn how acid is formed, what are the uses of acid, and what are the properties of the acid, bases, salt. All of this you will be learning. So when you take compounds in the nature, it can be divided into 3 groups. So one group is a acid, another group is a bases, and another group is going to be the salt. So first you will be studying about the acids, and then you will be learning about the bases, as well as you will be learning about the salts. So listen to me very carefully. So now when I say, can you name an acid? You will say yes. You will say, I'm going to name hydrochloric acid. Everyone knows naturally it is presented inside our stomach. We can say hydrochloric acid. It's an acid that is present as a gastric juice inside our stomach. So when you take this hydrochloric acid, now my question is, can you identify the ions present in the hydrochloric acid? Now when I say hydrochloric acid, it is a compound. Always remember, acid, bases, salts, all of them are compounds. They are compounds. So now I have taken hydrochloric acid. It is a compound. Now if you take a compound, always remember, a compound will have positive ions, as well as they will have negative ions. They will have what? Negative ions. Now, can you tell me what are the ions that is present in the hydrochloric acid? Now, by right now, you should be able to identify. You have to identify how to find the ions. So, we know if I take the hydrogen separately, we can have H plus ion. Isn't it? Like accordingly, we studied in the unit 3. Now, if I take the unit 3 of your grade 10, you know how to find the ions based on their valencies. So you know that hydrogen, they always likes to remove electron. So whenever an element removes an electron, they will have the positive
ion. Then if I take the chlorine, so if I take the chlorine, they likes to accept electron because they are on the other side of the periodic table, because they are high in electronegativity. So which means we can say chlorine likes to accept electron. So if an element accepts electron, we can say they will be negative ion. So these are the ions that is present in an acid. Did you understand? Did you understand? So always remember, if you have no idea with the periodic table, the first thing that you have to know what? The first thing that you have to remember the periodic table. If you don't know the periodic table, please draw the periodic table. On top, you can write the valencies and you can keep it. And the next thing is you should know the polyatomic ions. What are the 6 main polyatomic ions we have to remember? It's very important. In this lesson, polyatomic ion is very, very important. So what are the 6 polyatomic ion we have to remember? I'll write it down for you. So first one, hydroxide. Hydroxide. The second one, ammonium, NH plus 4. Then the third one is sulfate, SO4, 2 minus. And the fourth one is nitrate, NO3 minus 1. You don't want to mention them 1, but you can just keep it as a minus, okay? Then, because since it's 1, we don't need to mention anything. We can just mention the sign. Then the fifth one is going to be carbonate, CO3, 2 minus. Then what's the next one? The sixth one is phosphate. So why do we need this? What's the reason we have to know these polyatomic ions? Because in chemistry, polyatomic ions, what? Polyatomic ions appears again and again in your paper. So why? Because when we study chemistry, we have to know the polyatomic ions. Now here we are learning about the compounds, right? We already studied in unit 3, right? So we learn if a sodium and if a chlorine, sodium is an element, chlorine is an element. When an element and element combine together, they will become compound. So when they're becoming compound, can you remember we studied sodium has the valency plus 1, chlorine has the valency minus 1. We forgot about the signs. What did we do? We exchanged and we created a compound where we gave them a chemical name. So that's what NaCl, isn't it? So same like that, here we will be learning lots of acid compound, basis compound, salt compound. So we will be learning about the compound, and we have to know what are the elements are involved in a compound. So that's the main reason that we have to study about the polyatomic ion. So whenever you take a compound, you should know it will have a positive ion as well as it will have a negative ion. Again, you can ask me why? Because positive and negative has an attraction. Positive and positive, they are same signs, they will repel. Negative and negative, they are same signs, again they will repel. So if you wanted to form a compound, they should have a positive ion as well as they should have a negative ion, right? Come here. Now when you take hydrochloric acid, what is the charge on the hydrogen? What is the charge on the hydrogen? It is plus. So when you take the chlorine, what is the charge on the chlorine? It is minus. So when you take the HCl, whenever you add something to the water, now what are we doing? Now we are taking this acid and we are adding that to the water. We are adding to the water. Now listen to me very carefully. You have to know this. This is very important. So what am I doing? I'm going to take the hydrochloric acid and I'm going to add to the water. So in science, when we say something about water, we say aqueous medium. What do we say? We call them as what? Aqueous medium. So if the sodium chloride, let's say, for example, now you have sodium chloride and they have mentioned like this. Sodium chloride aqueous. What does that mean? Is it just the salt? No. Salt plus water only. We indicate it as NaClAq, which means aqueous medium. So now when you say HCl, now if I write HCl and in bracket, if I write aqueous, what does that mean? That means hydrochloric acid plus water. Hydrochloric acid with what? Plus water. So when you say acid are main. That means what you have to understand when you talk about acids, the main part of the acid is whenever you put the acid into the water, if the acid is releasing H plus ion, that means the speciality of the acid is what? The speciality of the acid is to release H plus ion, hydrogen ion. What do you need to understand? Whenever you take the acid, they will always release what? They will always release hydrogen ion into water. So accordingly, if I take the acid, I can take acid into two parts. One, you call it as a strong acid. Another one, you call it as a weak acid. So what are the two types of acid are we going to study? One, we are going to study about a strong acid. Another one, we are going to talk about the weak acid. I will tell you what is the difference between the strong and the weak. Before that, did you understand that the acid will release H plus ion into the water? Yes. And if they are releasing H plus ion into the water, they are considered as what? Aqueous. They are considered as what? Aqueous. Right. So now tell me, first of all, did you understand? Did you understand? Right. Great. Okay. So how will it release in the sense? Most of the acids, they are rich in hydrogen ion. They are rich in hydrogen ion. So when we talk about acids, their speciality, like let's say you take something, like you take whatever the things, let's say each and everything has a speciality, right? Let's say, for example, now you are a person and you only choose what? You only choose pink color. That means that's your speciality. If I wanted to identify you, I will say, okay, she's a person who is obsessed with pink color. Same like that, when we take the acids, their main character, their main property is to what? Release hydrogen ion, because all the acid contains specially hydrogen. Did you understand that? So since they all contain hydrogen, they release hydrogen ion into the water. That is their specialty to identify the acid. Okay, right. Yes, it will break down. It will break down. I'll explain that when we come to the strong and the weak. And someone told me they didn't understand the aqueous medium. Okay, dear, look here. Look here. Now, if you take the acid or if you take anything, let's say, for example, you have salt. You have salt. Now, if I have a solid salt, I will say sodium chloride solid, isn't it? And also, if I say if the salt is mixed with water in science, we don't mention it as a water. We simply indicate sodium chloride with aqueous medium. That means the sodium chloride is in the liquid form. It is in the liquid form. Why? Because it contains water. Did you understand? So aqueous medium in the sense it contains water. It says it contains water. Did you understand? Clear with that? You got the point? Yes? Right. Okay, now come here. Now come here. We'll talk about the strong and the weak acid. Okay, listen to me carefully. Now, if I take the acid, I can divide the acids into two types. One is the strong acid. Another one is a weak acid, right? So when you talk about the strong acid, we have to know the common strong acids that we know. So what are the common strong acids? Hydrochloric acid is a strong acid. Sulfuric acid is a strong acid, H2SO4. Nitric acid is a strong acid. And also we have a weak acid. We also have weak acid. What are they? Number one, we have carbonic acid. We have what? Carbonic acid. Then we have the phosphoric acid. We have the phosphoric acid. Okay. We have the phosphoric acid. And then we have the acetic acid. Acetic acid. So now listen to me carefully. Now, can you tell me what is the common element that has been repeated again and again in all the acids? You can see hydrogen, 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 hydrogen. That's why I told you that hydrogen is released into the liquid medium. They are being released. So the speciality of acid is to release what? Hydrogen ion. They will release what? Hydrogen ion. Right. Now listen to me carefully. Now we have to study about the strong acid and the weak acid. So let me explain you something. Now what is the strong acid and weak acid in the sense? Before I go to the main part of them, let me explain you the difference between the strong acid and the weak acid. Let's say this is the wall. Okay, let's say this is the wall. Okay, let's say this is the wall. Now this wall is made out of brick. Let's say this wall is made out of brick. Okay, and here also you have a wall and it is also made out of brick. It is also made out of brick. Okay, now when it comes to strong acid, you know that let's take it as hydrochloric acid. Let's take the wall as a hydrochloric acid. Okay, so now what is happening is if the wall completely breaks, if the wall completely breaks into two separate parts like hydrogen ion and chlorine ion, that is going to be the strong acid. Listen to me. Then what is a weak acid in the sense? Weak acid means this wall is not going to break completely. A part of this wall will be broken. A part of this wall will be broken. That means, now say if the wall is completely broken, you have to build it from the beginning, right? So if you break this wall, like means you can't build it back. Imagine you can't build it back. Okay, so strong acid, what you need to understand, they will completely ionize in the sense hydrogen will be removed from the chlorine will be removed from the hydrogen. That means they will become two separate ions, not as a compound. The compound will be completely broken under the strong acid. But in the weak acid, you have to understand the wall. A part of the wall will be broken. Let's say one brick has removed. Still the compound is existing. Still the wall is existing. So what can I do? I can take the brick and I can fix it back. That means I can reverse it. I can reverse it. It is reversible. It is reversible. So that means in the weak acid, let's take the carbonic acid. If I take the carbonic acid, a small part of carbonic acid will be removed. Still the carbonic acid will be there. Still the carbonic acid will be present. So that is what we call it as the weak acid. They will have incomplete ionization. So incomplete ionization means what? They are not completely broken into ions. Still they are existing as a compound. But here in the strong acid, they are completely ionized, completely broken. They are not existing as a compound. So that's we call it as what? Strong acid. And here we call it as what? Weak acid. Clear with that? Got the idea? Now if you ask me, teacher, will they ask this in our exam paper? No. They will not ask you in exam paper. But there is an important part. They can ask you in exam paper. They can ask you to write the strong acid according accordingly, like you have to write it in a chemical way. How are they getting ionized? How are they incompletely getting ionized? So you have to show in a chemical formula. In a chemical formula, you have to show how are they being ionized. I will show you, but before that, did you get the idea what is a strong acid and what is a weak acid? So strong acid in the sense, what do you mean by strong acid? So strong acid means you have to understand that the compound will completely break. Hydrogen will become separated, chlorine will become separated. So that means a complete ionization will be taken place in strong acid. But in the weak acid, incomplete ionization, still the compound will exist. A part of a compound, like any ions, can come apart. It can come apart. Incomplete ionization take place in a weak acid. Clear with that? Got the idea? Understood? I will show you in a chemical formula way, but before that, did you understand the concept here? Right. So you have understood. So listen to me carefully. Let me show you how this is working. Okay? Look here. Okay, look here. So now say, listen to me carefully. Now, if I wanted to show the strong acid, if I wanted to show that the strong acid has completely ionized, so completely ionized. So how will you show in a chemical way, like in a scientific way, completely? If it is completely ionized, you have to know that now. You have to know how it has been ionized, isn't it? So how would you show it? Acid, and it is a compound. And you will put an arrow in front. So you are putting an arrow in front and you will say hydrogen ion plus and chlorine ion. So this is the complete ionization. This is how you are showing. And you have to make sure that they should have the aqueous here. Why? Because they are inside the water. They are mixed with the water. I told you, acid, they will release hydrogen into aqueous medium, which means you have to show this hydrogen is released into the aqueous medium, chlorine also removed into the aqueous medium. So this means this is how you are supposed to show. This is the way you are supposed to show that the strong acid with the equation. So this is the chemical equation. So we have to see whether they are balanced. How would you see whether they are balanced? Always remember, in chemistry, if you don't write the balanced chemical equation, you will not get your marks. You will not get the marks. Why? It's a must. It's a must in chemistry. Maybe when you are in grade 10, they didn't consider. But in grade 11, definitely they will consider whether you are making sure that you mention with the balanced chemical equation. So how can you see? Just divide this side and the other side. You can see hydrogen, chlorine, hydrogen, chlorine. How many hydrogen do I have? One. Here also one. Balance, balance. How many chlorine do I have? One. And here chlorine, one. They are balanced. So that means this equation is balanced chemical equation to show they are what? Strong acid. Let's talk about the sulfuric acid, H2SO4. So we know that what are the ions are present in the sulfuric acid? We can take hydrogen. We can take hydrogen ion. SO4, it's what? What is it? It is a polyatomic ion. It's a sulfate. So you can take the sulfate separately and you can mention like this. And this is also going to be aqueous. So this is how you show the equation, that's the strong acid undergoing complete ionization. But before that, check whether they are balanced. Check whether they are balanced. How can I see? What are the elements do I have here? Hydrogen, sulfur, oxygen. Here, hydrogen, sulfur, oxygen. How many hydrogen do I have in this side? 2. Here, 1. How many sulfur do I have? 1 sulfur, 1 sulfur. And how many oxygen do I have? 4. Here 4. That means sulfur, sulfur, oxygen, oxygen, they are balanced, but not the hydrogen. But in this side, I have to balance. How can I do? I can multiply by 2. That means I can add a 2 in front of the hydrogen to make sure they are balanced. To make sure they are balanced. Did you understand? Did you understand? Clear with that? For the strong acid, for the equation, we only use one arrow. We use only one arrow. Why? Because they are completely ionized. They are irreversible. You cannot reverse them back. You cannot reverse them back. So this is how you show chemically they are completely ionized. That means you should be able to understand. You should be able to identify what are the ions are present in this compound. If you know what are the ions are present and with their valency, then that's fine. So that's it about the strong acid. That's it about the strong acid. Now, can you come to the weak acid before we go to the weak acid? Yes. Hold on. Teacher, only in aqueous medium it will break down when added water. Of course, yes. Most of the time acids are with the aqueous medium, like they will only break in the aqueous medium. Yes. Okay. Right. So I hope you are clear with the strong acid and you got to know how to show them chemically. They are completely ionized. Now, shall we go to the weak acid? I will show you how the weak acid, how you can indicate them. How you can indicate them. Yes. Yeah. Okay. Look here. Look at the board. Okay. So now look here. Now, in the weak acid, they are incompletely ionized, right? In the weak acid, they are incompletely ionized. Incompletely ionized in the sense they are reversible. So, in the weak acid, they are what? They are reversible. So if they are reversible, we will use double arrows, like reverse arrows, double arrows. Let's take the carbonic acid, H2CO3. H2CO3. So now when I take the carbonic acid, you know what are the ions are present in the carbonic acid? Can you tell me what are the ions are present in the carbonic acid? Yes. We have hydrogen, we have H plus ion, and we have carbonate ion. We have the carbonate ion. Okay, so still the compound, carbonic compound will still be present. Still be present. And how can I indicate it? Double arrows like this. You have to indicate it using the double arrows. When it comes to weak acid, you have to use arrows like this. Why? Because they are not completely ionized. They are incompletely ionized. So you can check whether they are balanced. No, they are not balanced, isn't it? They are not balanced. So since they are not balanced, how can you mark them? How can you mark them? So this has to come other way around. Okay, right. Now this part is balanced, this part is balanced. You can add a 2 in front of the hydrogen to make them more balanced, right? Can you try for the phosphoric acid? Can you try for the phosphoric acid? You can just write it by yourself. H3PO4. And how can you make sure that they are in the weak acid? You use these arrows and you will write H plus ion plus PO4 3 minus phosphate, both the side, it's balanced. And here 3 hydrogen, you can add a 3 in front of that. You can add a 3 in front of that to make sure they are well balanced. So always remember, if the reaction taking place as a complete ionization, you indicate it by a single arrow. If the ionization is taken place incompletely, you will use double reverse arrow to show they are what? They are weak acid. Clear with that? Got the idea? Understood? Clear? Right. So you have understood what is a weak acid and you have understood what is a strong acid. Right. Now this part comes to your MCQ. O-level paper. You can take any O-level paper. MCQ, you will have this kind of question. Let me show you what kind of question you will be facing. Okay. So now, okay, listen to me. Now, what I have to tell you is, now if I take nitric acid, if I take the nitric acid, can you identify whether they are strong acid or a weak acid? Now you have to know what are the three acids that is belong to strong acid. Number one, what is that? Number one, I said you nitric acid, hydrochloric acid, sulfuric acid. You should know the name. You should remember the name. And then if I'm talking about the weak acid, phosphoric acid, carbonic acid, acetic acid will come under the weak acid. Now, if I wanted to show the ionization in the nitric acid, we have to know whether they are strong or a weak acid. If they are strong acid, we will use a strong one arrow to show what? To indicate they are what? To show that they are what? They are completely ionized. But listen to me very carefully. Now listen to me. Now I said that strong acid is added to the water, right? Now I said you strong acid is added to the water. Listen to me carefully. This is very important, okay? Now what you learned, I'm slowly encouraging you to understand the advanced part of this. Listen to me. Now nitric acid is added to the water. That's why I said that acid will release H plus ion in an aqueous medium. So you should not forget, in the weak acid as well as in the strong acid, there will be water. There will be water. So what you have to understand is water also will undergo ionization. If the water is undergoing ionization, they will always undergo incomplete ionization. So this is the nature of the water. Water can't undergo complete ionization. They can only undergo incomplete ionization. Incomplete ionization. So if they are undergoing incomplete ionization, what will be the ions present in the water? So if I'm taking water, H2O, you will indicate it by double arrow, which will be H plus ion plus OH minus hydroxide ion. So this is how still we can say there will be presence of water. There will be presence of water. Why? Because it is an incomplete ionization. So you have to know. Now you have nitric acid. It's a strong acid. Will it undergo complete ionization or incomplete ionization? It will undergo complete ionization. But still, if this nitric acid is with water, this nitric acid will undergo complete ionization, but the water will not undergo complete ionization. It will undergo what? It will undergo incomplete ionization. Now listen to me carefully. Now in exam paper, they can ask you, select the ions that is present in nitric acid aqueous medium. So now they have given you 4 options, okay? They have given you 4 options. Option number 1. Now I don't want to give you options. Let's see what are the ions are there. Now if I take the nitric acid, now what are the ions will be there if this is a strong acid? If this is a strong acid, can you tell me what are the ions will be there in the nitric acid? Completely H plus ion, and I can have NO3 nitrate. I can have NO3 minus. So I can have this complete ion. So these are the ions that is present in the nitric acid. Now, since I have mentioned aqueous, don't forget there is water. So you also have water. From the water, you have the H plus ion as well as you have OH minus ion. Now, since I have mentioned 2 times the H plus ion, do I really wanted to mention mention the H again, H plus ion again? No need. So what are the ions that is present? H plus ion, NO3 minus ion, OH minus ion, and still the incomplete particle of the water is still present. So these are the ions that is present in the nitric acid aqueous medium. Clear? Got it? Understood? They can ask you, they will give you 4 options. You are supposed to underline that. You're supposed to underline. You're supposed to understand that. Right. Okay. Now come to the carbonic acid. Now carbonic acid is a weak acid. So if it is a carbonic acid, how you will be able to identify the ions in the carbonic acid? Now let's say carbonic acid. Yes. So now if I take the carbonic acid, so you should be able to identify, isn't it? So now if I take the carbonic acid, they will undergo complete ionization or partial ionization, incomplete ionization. So if that is the incomplete ionization, how you will be able to write it down? How you will be able to write it down? And also they have mentioned it as aqueous medium. How can I write it? Simple. Already you will have carbonic ion. You will already have a carbonic ion. Why? It's not completely ionized. Incomplete. Still the particle is present. And you will have a H plus ion. And you will have CO3. 2 minus also. Again, aqueous. You have water. And again, from the water, it will release H plus ion and OH minus ion. So since I have already mentioned H plus ion, do I want to mention this again? No need. So these are the particles, these are the ions, these are the compounds and ions that is present in the carbonic acid aqueous medium. This is how they will ask in your O-level MCQ paper. Every MCQ, you will have a question like this. You will have a question like this. So finally, let's go with the phosphoric acid, will you? Let's go with the phosphoric acid, H3PO4. So, and it is aqueous medium. Can you tell me what are the compounds and what are the ions that is present in this carbonic acid aqueous medium? Simple. You can write the carbonic acid will be, phosphoric acid will be there. Again, H plus ion, PO4, 3 minus. And again, what else you will have? You will also have OH minus ion, water. These are the things you will be having in the phosphoric acid. So that's it about the acid. That's it about the acid. Clear? I just explained you about the acid. Still, I didn't come to the properties of acid. Still, I didn't teach you the uses of the acid. I will come to the uses and the properties. But before that, can you confirm that you understood? Can you confirm that you understood? Yes? Got it? Right, great. So now you have understood about what? You have understood about the acids. So now let me talk about the properties of acids. Now you may have heard about the acids. Like we have seen so many films, we have seen so many videos. If acid come in contact with our skin, if the acid come in contact with our skin, we know our skin will be melted, isn't it? Our skin can be melted. So that means, what is the first property? What is the first property of the acid? Yes, the first property of the acid is they are highly corrosive. Highly corrosive in the sense what? Highly reactive. They are very, very dangerous. They are very dangerous. They are highly corrosive. So that's going to be the first property of what? Acid. So they are very, very dangerous, highly corrosive. Then what is the next one we can say? What is the next one? So you might have seen, like if you have gone to the lab, you have seen they have shown the one hand. They have shown the hand like this and like this, and they have shown like you are not supposed to touch the acid because it can dissolve your skin. It can also dissolve the metal, that much powerful. And then what is the acid that we use at our home? The citrus fruits. If we talk about the citrus, Yes, if we are talking about the citrus fruit like lemon, lime juice, and then if you take the orange, then what else? Where you find the citrus, they are, what is the taste of that? What is the taste? Yes, what's the taste of these acids? What do you think? It's the sour taste. So the property of the acid is sour. So just because of that, can you drink the hydrochloric acid? No, it's not good. It's dangerous. So we can say the special property of the acid is what? They are sour in taste. They are sour in taste. So when you talk about acid, okay, so when you talk about acid, some people they confuse, okay, so lime water is different, okay dear. Lime water is a different one. Lime juice is a different. Lime juice is a different. Lime juice is a acid, while lime water is a base. It is a base. So don't get confused, okay? So lime water is calcium hydroxide. It's calcium hydroxide. Lime juice is the lemon. It's from the lemon, okay? Right. So then when you talk about the acid, what are the other properties we can say? What are the other properties we can talk about the acid? So acid has what? Other than this, there are so many properties. Still, we didn't talk about the bases, right? Since we didn't talk about the bases, I will compare it with both of them and I'll explain you, okay? So we'll talk about the bases. After that, we'll come to the properties of the acid and bases. They are going to be similar, quite similar and opposite. So let's talk about the uses. If you're talking about the uses of the hydrochloric acid can remove rust from the steel object. They can also get to refine common salt. From the hydrochloric acid, we can produce salt. And also we can produce chlorine from the hydrochloric acid for bleaching cloth, thread, and everything we can do. And what else? We have the natural power of hydrochloric acid inside our stomach to digest the food. And also we make gelatin from bony materials using the food technology, using the hydrochloric acid. Those jelly, marshmallows, and we buy this gummy bear and everything. So all we get from what? This hydrochloric acid. And also acetic acid. Where do we use acetic acid? It's a colorless one. Vinegar, like we make it for the vinegar. It's a weak acid, no? So we make synthetic thread. We coagulate rubber latex, paper industry. We use it in the paper industry. And have you seen in the old days, like during the times of our great grandfather, our grandfather time, they used to wash the photographic films and give you the photos. Like they give you photos, like they go to the dark room and they will wash that photos and they will give you them. Yes, that is all using the acetic acid. Then sulfuric acid, it's a strong acid. We use it for what? For the detergent, paint, plastic, and also we used to make dye, fiber and dye. And also we use it to produce gases like dehydrating gases and everything we used to make using the sulfuric acid. So these are the ideas of the acid. There are more properties. I will compare it with the bases and I'll explain you. Then that's easy for you to understand. Right. Come to the bases. So bases also going to be same like the acid. You have the strong bases. You also have the weak bases. So you will compare both of them and you will be learning about it. Right. Again, come here. Okay, listen to me. So when you talk about the bases, they will release H minus ion into the aqueous medium. So that's the speciality of the bases. So if I take the bases, there are two types of bases. One, you have the strong bases, and another one, you have the weak bases. So strong bases will undergo what? Complete ionization. They will undergo complete ionization. Already you know what's an ionization, right? Completely the compound will be broken down. But the weak bases, they will have the incomplete ionization. So what are the strong bases we know? Number one, we have the sodium hydroxide. Then number 2, potassium hydroxide. Number 3, calcium hydroxide. So then these are the strong bases. So what are the weak bases we have to know? Weak bases, they will undergo incomplete ionization. So how? We remember magnesium hydroxide. So magnesium hydroxide. Then ammonium hydroxide. Ammonium hydroxide. Then what else? So we have ammonium hydroxide. We also have magnesium hydroxide. So these all will come under what? These all will come under the weak bases. So same like you did for the acids. Like how can you show chemically like they are being ionized? How can you show? You can break down what are the ions are present in the sodium hydroxide. Na plus OH minus. You have to show they are aqueous. You have to show they are aqueous. So this is how you are showing in a chemical way, in a scientific way, how they are undergoing complete ionization. Now, if it's a weak base, magnesium hydroxide, how would you show? Magnesium hydroxide, we'll put a double arrow, right? Don't forget, you should mention double arrow. And then magnesium 2 plus, aqueous, and OH minus. And you have to see whether they are balanced. How would you see they are balanced? So you have to add a 2 in front of the hydroxide, since the hydroxide is having 2. Clear? Same like what you did for the acid, you have to do it for the bases too. And you know, if you know that all of them are present with water. This is also with water. This is also with water. So if they ask you to identify, can you mention what are the ions and compounds present in the potassium hydroxide? What are the ions and compounds present? You will write it down. Potassium, K plus, OH minus. And you will also have water, because water will undergo incomplete ionization. Again, you will mention H plus ion will be there. Do you wanted to mention the OH minus again? That is from the water? No need, because already you have mentioned. So these are the ions and compounds that is present in the potassium hydroxide. Now let me tell you for the ammonium hydroxide. So if it comes with the ammonium hydroxide, can you tell me what are the ions and compounds that will be present in the ammonium hydroxide? Yes. What are the ions will be present? What are the ions might be present? Yes. Ammonium hydroxide, ions and compounds. Yes. Can you tell me? You will have ammonium. You will have OH minus. And you will have H plus, water. And again, you will have ammonium hydroxide. So these are the things that will be present in ammonium hydroxide. Clear? Got it? Understood? Any doubt? Any doubt in it? Any doubt? Clear with that? So that's it about the bases. So let me talk about the properties of bases. Properties. So when it comes to bases, always remember bases are bitter in taste. They are very, very bitter in taste. Okay. So the special property of bases are they are very bitter. Their taste is bitter and they will have a slimy texture, soapy texture, like slippery, soapy texture. You can find it under the base. They will have the slimy texture. So now you know the common properties of bases, and also you know the common properties of the acid also. So right now you have to study something called neutralization. You have to study neutralization, as well as you have to study something called salt. You have to talk about salt. So listen to me carefully. Let's talk about the salt and you will get to know more about it. Listen to me carefully. Now, when you take sodium hydroxide, now you know sodium hydroxide is a strong base or a weak base. It is a strong base. I'll mention it as SB, as a strong base. Now say, if the strong base is reacting with the strong acid called hydrochloric acid, strong acid, hydrochloric acid. So now can you combine both of this compound? You know very well, you have studied how can you combine both of the compound. You have studied in unit 16 double displacement. Haven't you learned? You have studied the double displacement chemical reaction, right? So how can you say what are the ions are present in the sodium hydroxide? Na plus, and you have the OH minus. I'll write it down simply. OH minus. And then you have H plus ion here and Cl minus here. Cl minus here. So you know this is a couple, this is also a couple. So if this is positive, if they wanted to attract to the other side, they should be negative. So sodium will go and react with the chlorine, while hydrogen will go and react with the hydroxide. So this is the double displacement. So what will be the outcome? What will be the outcome? You will form sodium chloride. You will form what? Sodium chloride plus hydrogen plus hydroxide. You will be forming water. So this is going to be the salt reaction. So what you need to understand, if a strong acid or a strong base, they combine together, they will form salt plus water. They will form what? Salt plus water. So combination of acid with bases, they will form salt plus water. Does it only happen for the sodium hydroxide and chloride? Hydrochloric acid? No. You can also take the potassium hydroxide combined with the weak acid. We can say as what? We can say, like let's say carbonic acid. Let's take the carbonic acid. So if I take the carbonic acid, potassium hydroxide with the carbonic acid, you will form what? You will also form salt. What is the salt you will be forming? Yes, you can also form potassium carbonate. You can also form potassium carbonate, right? So potassium carbonate plus water. This is also going to be a salt. But look here. So look here. Here you have the strong base. And here you have the weak acid. Here you have the weak acid. Always remember, if a strong base combines with the strong acid, you will always form a salt which is neutral. You will form a salt which is neutral. You will form a salt which is neutral. But if a strong base combine together with a weak acid, can you tell me who is dominant here? Who is dominant? Who is bigger here? The strong base is bigger. So that means you will form basic salt. You will form basic salt. So let me take the another one example. Like if the strong acid combines with the weak base, means you will form acidic salt. You will form what? Acidic salt. So these are the things you have to know under the salt. Clear? Got it? Understood? So that means whenever an acid combines with the base, they will form salt plus water. They will form what? Salt plus water. So that means if a strong base combine together with a strong acid, they form a neutral salt. When a strong base combine together with a weak acid, who is the bigger person there? Strong base. So strong base, because of that, you will form a basic salt. If a strong acid combine together with a weak base, they will form the acidic salt, because here this person is a dominant person. Clear? Got the idea? Understood about the salt? Did you get the idea about the salt? Yes. Right. Now we have to go with the lesson. In the part of the lesson called neutralization. I'll keep it here itself and you will understand neutralization also a part of this lesson. So neutralization means if you have an acid, you know that acid will release H plus ion. And if you have a base, and they will release OH minus ion, hydroxide ion. If a hydroxide ion and a hydrogen ion combine together, what are they forming? They are forming water. So this process, we call it as neutralization. We call this as what? Neutralization. So whenever an acid and a base combine together, if they are producing water, we call this process as what? Neutralization process. So when it comes to neutralization process, there are some situations that happens in our life. In our natural life, it happens. Neutralization happens inside our stomach. Just think now, if you have your stomach, now what is the juice that is secreted by your stomach? That is hydrochloric acid. Now you eat spicy food, you skip food, what will happen to the amount of hydrochloric acid? It will increase. So now you will say, doctor, I have gastritis. What your doctor will do? Your doctor will suggest you weak base. She or he will be suggesting you what? Weak base magnesium hydroxide. So we use milk of magnesia. So what will happen? Since you have the acid inside your stomach, to make sure that you are becoming neutral, your acidity has to reduce. What your doctor will suggest you? Your doctor will suggest you a base. Once you drink the base, acid and a base combine together, they will become what? They will slowly neutralize. Once they neutralize, they will produce water, and you will feel what? You will feel relaxed. So this is what we call it as neutralization. Clear? Neutralization take place inside our stomach also. Then you know wasp. You know wasp, right? The wasp, the big bee, the bumblebee, we say the wasp sting. So the wasp sting is like its base. The wasp sting is base. Let's say if the wasp, if they come and attack, the sting is inside your skin, it is a basic. It is a basic. Now, if I wanted to relieve from the pain, can I use the soap there? Can't. Why? Soap is a base. It will increase the pain. But if I use the, what do you say, vinegar, or if I use like, what do you say, if I use the lime juice, I will reduce my pain because I am using a weak acid. Better, whenever you wanted to cure from a pain, you make sure you're using a weak acid or a weak base, because can you use a strong acid or strong base? It can hurt you. It can break you. So because of that, you have to understand that if you have a basic inside your skin that is hurting you, you have to use an acid to form water. But if you have acid inside your body, and if you wanted to relieve from the pain, you have to use a base there. So that's the concept. That's the concept. Now think about the bee sting. If you talk about the bee sting, it's an acid. So if I want to relieve from the pain, what I can use? Baking soda, sodium bicarbonate, red ant bite. If the red ant bite, so red ant is what? What do you say? Red ant is a basic. So what I have to apply? I have to apply lime juice. I have to apply lime juice to make sure that the pain will reduce. Then, if in case if you are using the soap and if you are washing, what will happen? The pain will increase. Why? You have to know whether you have been attacked by the base or acid. So if you know them, you know to find the solution for it. So this is what we call it as what? Neutralization. So are you clear with the neutralization? Are you clear with the neutralization? Yes. Right. Okay. So there is the important point I have to tell you. Always remember, you have studied in Unit 16, Grade 10. Can you remember you studied about the activity series? Can you remember you studied the activity series, right? So this is related to the property of the acid, okay? This is the property of the acid. Now you know about activity series. You should know the activity series. It's a must as you are a grade 11 student. You are in your second term. You should know your activity series. Unit 16, grade 10. So you should be able to know. So what are the activity series you know? Potassium, sodium, calcium, magnesium, aluminium, zinc, iron. Then you have the tin, you have the lead, You have the lead and you have the hydrogen. Let me stop from the hydrogen. So always remember, whatever the elements which is above the hydrogen, if they react with hydrochloric acid, they will produce hydrogen gas. So this is the property. So what is a property? A property of an acid. If any acid, if they react with the elements or metals above the hydrogen, if they react, they will produce hydrogen gas. So that's what you have to remember. Clear? Got it? And also another property. If any carbonate, okay, if any carbonate, if they react with any acid, if any carbonate, if they react with any acid, they will produce carbon dioxide gas. For example, calcium carbonate is reacting with hydrochloric acid to form calcium chloride plus carbon dioxide plus water. So that means you have to understand, if any carbonate, this is the carbonate, if that is reacting with hydrochloric acid, they will be forming carbon dioxide. So you have to know the gas they are producing. So this is also one special property of acid. This is also one special property of an acid. Clear with that? Got the idea? And then I forgot to tell you about what? The uses of bases. So what are the uses? Sodium hydroxide, we used to refine petroleum products. We use it in the lab as a strong base. We produce soap. To make soap, we use sodium hydroxide. Artificial silk, paint, paper, we use sodium hydroxide. Then magnesium hydroxide, we use it as a medicine, right? So we use it as a medicine to purification of molasses in the sugar industry. And also, yeah, for those purpose, we are using magnesium hydroxide. And also, you know about the salt, right? You know very well about the salt, isn't it? We use for the cooking. We use salt for cooking, flavorings and everything. So you know about the salt. Right. Now we learned about the acid, bases and salt. The only thing that we have is indicators. We have to study about indicators. After that, the lesson is done. After that, this lesson is done. So shall we talk about the indicators? Yes. Let's finish the lesson, okay? Let's finish it. Only very few parts you have to learn. Indicators. After the indicators, the lesson is done. Right? Okay, so look at the board. Listen to me carefully. So let's talk about the indicators. Let's see what is this indicators. Okay, listen to me carefully. So indicators means, like, listen to me. Now we don't know how to find the acid and we don't know how to find the bases. Now we say that the acid releases H plus ion to aqueous medium. So let's say, for example, now I'm taking acid. I'm taking 1 drop of acid. I'm putting into the water. Can I see that the acid, hydrochloric acid, is releasing H plus ion? Can I see? Can't. So to identify the substance is whether acid or a base, I need an indicator. So indicator means it is a substance that will give you, that will indicate one color. Let's say, for example, listen to me very carefully. Now what you need to understand is, you need to understand clearly. Listen to me very clearly. Now say, for example, now you have a traffic light. You have the traffic light, you have 3 colors. You have the red, you have the orange, and you have the green. So when you have these 3 colors, listen to me carefully. Now when you have these 3 colors, now say you are in the vehicle and you will be standing for the red. That means red is indicating you to stop. And orange is saying, okay, wait. And then this, what do you say? This green says that you can go. So that means it is indicating you, right? Indicating something. So when you talk about the indicators, it is a substance. It will show a color. That color will say, okay, this is a base, this is an acid. They will give you one color to identify whether they are base or an acid. That you call it as what? You call it as an indicator. So say, for example, now you have an indicator. Have you ever used natural indicator at your home? Natural indicator, turmeric. Have you used turmeric as an indicator? So turmeric is a natural indicator. So let's say, for example, if I have the turmeric, like if you want, you can try, take the turmeric and you add some soap. You add some soap to the turmeric, and when you mix that, you get like around red color. You get it like a red color. What does it show? That red color shows the presence of a base. That means the turmeric will show one color for the acid, it will show another color for the base. Like red cabbage, it will show one color for the acid, it will show different color for the base. So these are natural indicators in your home. So we are going to study the indicators which is present at your lab, which is present at your lab. So the first indicator that we are going to learn is litmus paper. Litmus paper. So you have two types of litmus paper. One is a blue litmus, another one is a red litmus. So red litmus paper is used to identify the acid, while the blue litmus paper is used to identify the base. So that means you have to understand clearly. You have to understand clearly. So now you have the substance. Now we don't know. Let's say, for example, now if listen to me carefully. Listen to me. This is something you have to understand. Let's say, just listen, you have two types of litmus paper and you have base here and you have the acid here. So when I use the red litmus paper into the acid, there will be no color change. There will be no color change. But if I use the red litmus paper into the base will make the red litmus paper blue color. It will turn into a blue color. And then if I take the blue litmus paper and if I put into the acid, there will be a color change. It will turn into red color. While the blue litmus is added to the base, it will not change color because it is already exist as a blue. So you have to understand the color. You have to understand the color. So that means blue litmus is neutral to the base. Red litmus is neutral to the acid. So you have to understand clearly. You have to understand what? Clearly. So this is one of the indicator. Then what is the another indicator we can use? What is the another indicator? We have another indicator. We call it as phenolphthalein. Phenolphthalein. So phenolphthalein is another indicator. It's a white color powder. Okay, it is a white color powder. So this white color powder, it is mixed with the surgical spirit. We mix it with the surgical spirit, and most of the time, you know, surgical spirit is a colorless solution and we are using for the cleaning agent of your wound, isn't it? So if I dissolve the phenolphthalein powder, it will not dissolve in water. It will only dissolve with the surgical spirit. So what will happen is, when I use the phenolphthalein, let's say I have the acid here, I have the base here. So when I use the phenolphthalein into the acid, and if I use the phenolphthalein into the base, I will get two different colors. So that means phenolphthalein, when I add into the acid, there was no color change. That means it was just normal colors. It was colorless. It was colorless, but when I add the phenolphthalein into the base, it turned into pink color. So that means phenolphthalein is an indicator to identify the base. Phenolphthalein is an indicator to identify the base. Only base you can identify. Can you identify the acid? Can't. Then let's take the methyl orange. Let's take the methyl orange. If I take the methyl orange, it is a yellow powder. It is a yellow powder. So when I take this yellow powder mixed with the water, it will turn as a yellow solution. So again, if I take the base here, and if I take the acid here, if I put the methyl orange into the acid, it will turn into orange or to red color. It will turn into what? It will turn into red color. So that means this methyl orange will show red color, that shows the presence of acid. And the methyl orange, if I add to the base, it will remain colorless, which means it is neutral. It doesn't show any changes. So that means I can say methyl orange is an indicator to identify the acid. Methyl orange is the indicator to identify what? Identify the acid. So, have you gone to the magic shows? Yes. Have you gone to the magic shows? What are they doing in the magic shows? They are using science. They are using science. They use science to show the magic. They change the colors from this color to that color, you all look like amazing. You say it's amazing. Why? Because they are using the science. They are using science to show you the, what do you say, to show you the magic. It's not magic, it's all science they are using, right? Clear with that? So this is an indicator. So methyl arrange is used to identify the acid. It is an indicator. It will turn into red color. Then phenolphthalein is a white powder. You mix it with a surgical spirit. It is also used to identify the base. It will give you the pink color, but here it will remain colorless. Here in the base, it will remain colorless. Then finally, you have another indicator. That's going to be the pH paper. That's going to be what? pH paper. So if you take the pH paper, most of the time, pH paper will have, what do you say? It is a yellow color paper. So what are the colors in the rainbow? We remember as what? Vib, G, Yor. So Yor is the colors that you have in your pH paper. So if you take the pH paper, you will have 14 colors, like you will have 14 parts. So if you take the pH paper from 1 to 6, the number 1 to 6, it indicates what? It indicates acid. From 1 to 6, it indicates acid. From the 7, it says it's a neutral. That means the substance is neutral. From the 8 to the 14, it will indicate they are bases. So they will have the numbers. That numbers will show you what? They will show you that they are bases. So always remember, if I'm talking about the Vibgyor, like look at the color value. If I talk about the Vibgyor, I have to put the other way around. Like let's say red, orange, yellow, green, blue, indigo, violet. Let me put into this way. From the red to yellow, it indicates the acid. That means if our pH paper turn into red color or orange color or yellow color, it shows they are acidic. So red color indicates that they are strong acid. Yellow color indicates they are weak acid. So green color is neutral. And from the blue to the violet, it shows they are, what do you say? Weak acid to the strong acid. Weak bases to strong bases. So these are the pH value ranges. So you have to just understand the ranges. From 1 to 6 means it's acidic. From 8 to 14 is the basic. The 7 is going to be the neutral color. So these are the things you have to know. Clear with that? Got the idea? Any doubts in the lesson? We are done with the lesson. We are complete with the lesson. So lesson is over. This is a simple lesson. You have to know what is an acid. You have to know what is the base. You have to know what are the indicators. You have to know what are the properties, as well as you have to know how to identify the ions and compounds. And finally, you have to know to balance the chemical equation. So these are the things you have to know. So that's it about the lesson. Like around 3% of this lesson will be appearing in your O-level MCQ paper. Mainly MCQ. By chance, you can get it combining with the other chemistry lessons. This lesson can come like two, 3 questions can come, like balance the equation, identify the compounds. So what are the examples for the bases? What are the examples for the bases? Soap. We can take the soap. The slippery, slimy texture is the soap. We can take the soap as the best example for the bases. Then we also have the sodium hydroxide, potassium hydroxide. These all are best examples for the, what do you say? If you see something that's slimy, slippery and all, those are considered as what? Bases. Like we make the shampoo, it's a base. If you take the things that is like, what do you say? That has a bitter, like foamy things, those are bases. Okay, right. So that's it. We are done with the lesson. And that's it. You have to know about the lesson, right? Okay. Okay. So usually our classes will be taken place on every Wednesday, 6:30 p.m. So every Wednesday, 6:30 p.m. onwards, we have our classes, as well as, you know, our classes we have on Wednesdays, we have our theory class. We have our theory class on Wednesdays, and Saturdays we have our revision classes. So usually revision will be take place. Whatever we complete in our theory class, we will be doing questions. We will have model questions. We have past paper questions. We also have revision questions to be completed on Saturdays. Every day that's going to be 8:30 p.m. So we will be doing questions there, whatever you study in the theory classes. So you will have 8 classes per month. So 8 classes per month. You also, yeah, you will be having, yes, you will be having 8 classes per month, and that's going to be 2,200 if you're only going to join the grade 11 batch. Okay, so if you're only joining grade 11, and you will be having 2,200 only, right? So you can just contact me if you're really interested to join the class, and have a good day. Take care. See you in the next class. And hopefully the theory students, you all can do the questions related to the acid, bases, and salts, and you all can get ready. Take care. Pleasure. Thanks a lot for the people who joined the class, and have a good day. Take care. See you. You are welcome, Yahya.